which I think is unfair. Okay, so let's say that I have a function here. I'm going to call it k of x. Instead of saying f of x, we'll say k of x. And k of x has a table of values that looks like this. So x and y, let's say x is negative 1, 0, 1, 2, 3, 4. And then on those x values, let's say y starts out at negative 5, jumps up to 1, jumps up to 3, jumps down to negative 1, jumps up to 4, and jumps back down to negative 2. All right, so let's say that we have the function k of x, and we're going to say that k of x is continuous, meaning that you could draw k of x without ever having to lift your pencil. There's no point discontinuities, there's no jump discontinuities, nothing like that. So if we were looking at this as a function, so at negative 1, the value is at negative 5, so it's somewhere down here. I'm just going to kind of eyeball these values. At 0, it's 1. At 1, it's 3. At 2, it's negative 1. At 3, it's 4. And at 4, it's at negative 2. So I'm just kind of eyeballing these values here. I don't really have a very good scale on my graph. But so if this is a continuous function, I could connect them just by going point to point to point like that. So that could be what the function looks like. However, the function could be more complex than that. The function could like jump up and back down and then back up again before it hits that value, and then up and down before it hits there, and up and down, and up and down, and up and down, and up and down. But this is as simple as it could possibly be, right? You guys with me so far? Okay. So do you remember from pre-calculus what it means for the roots of a function? Okay, awesome. That was a ringing endorsement. The roots of a function are the places where it crosses the x-axis. So every time it crosses the x-axis, that's a root or a solution to the function. So in this case, it has to cross the x-axis at least 1, 2, 3, 4 times. It could cross more than that, but it has to cross at least 4 times. Does that make sense? Kind of, sort of? So a root happens whenever the function crosses the x-axis. We don't care about it crossing the y-axis, it's the x-axis. So there should be a root somewhere in between negative 1 and 0, somewhere in between 1 and 2, somewhere in between 2 and 3, and another one in between 3 and 4. So there are at least 4 roots. There could be more, but there's at least 4. You guys with me on this so far? Okay, I see like one head nod. Great. Okay, thank you. All right, now, if I asked you how many times does k of x, or at least how many times does k of x have to equal 1 on this interval? How many times does k of x have to equal 1 on this interval? Well, there's one place right here,
4.
right, another place here, another place here, and another place here. So there would be at least 4 places, at least 4. I was meant to be, but then that's not what I meant to write, so I scratched it out. If I'm looking for when k of x is equal to, let's say, 3, at how many points on this line would k of x be equal to 3?
3.
So 1, and then it has to be equal to 3 here because it's going in between 0 and 4, and then it has to be equal to 3 here somewhere because it's going from 4 all the way down to negative 2. So there's 3 places where it has to be equal to 3, or at least 3 places. There could be more because it could do that whole oscillating thing. Yes?
So, what do you mean by k of x?
I mean the y value.
Y value?
Whenever you see k of x or f of x or g of x, it means the y value of the function.
Okay.
So k of x has to equal 3 at least 3 places in here. Now, it could have like another thing here, like it could do in between 0 and 1, and if that's the case, there'd be more than one place where it hits 3. But we know there's at least 3 places where the value is 3. Kind of, sort of? All right. So that's part of today's assignment. Now, let's talk about bisecting to find roots. So you have, I think, maybe 4 problems on today's assignment that are like this. that ask similar questions to that? So that's not too bad. Now let's say I have another function here. I'm going to call it L of x. And L of x, I'm not going to give any numbers to. I'm just going to show you generally what it looks like. Well, no, I will give numbers. Okay, how about I make it not so long? We'll make this -2, -1. Okay, thank you. Thank you for your feedback. And let's say L of x does this kind of meow, meow, and then meow. So L of x has 3 roots here. It has, I'll call this one A, I'll call this one B, and I'll call this one C. So we know for sure that L of x looks like that. It has 3 roots. Now, if we look at the value at -2, it's a positive value at -2. If we look at the value at +2, the function has a negative value, right? So because one value is positive and one value is negative, I know there has to be a root in there somewhere, a place where it crosses the x-axis. Okay, let me say that again. The value at -2 is positive. The value at +2 is negative. So because it goes from being positive to being negative, there has to be some place in between -2 and +2 where it crosses the x-axis. We're assuming that you can't see the graph here. That all you know is that at -2 it's positive and at +2 it's negative. So we're assuming that you're blind or whatever, or somebody's describing this to you. Okay? So you can't see the graph, but you know that there has to be at least one root somewhere in between there. Okay? All right. So now, the bisection way of finding a root means that we're going to take -2 to 2, and we're going to bisect that. We're going to find the middle of it. So what's the middle from -2 to 2?
0.
Great. We're going to take the function, or the value of the function at 0. Okay. We're going to bisect -2 and 2, meaning we're going to cut it in 2. We're going to find the middle. So what's the middle from -2 to 2? Okay. Now, we're going to reevaluate only these 3 points. The point at the value at -2, the value at 0, and the value at 2. We're going to pretend like we can't see what's happening in between here. Okay? Now, both 0 and +2 are negative values, so that means that there isn't necessarily a root in between these two. Okay? However, -2 is positive and 0 is positive, which means that there is definitely a root in between these two. So I'm going to forget that the second half of the graph doesn't exist, and I'm going to check to see if there's a root in between these two numbers, between 0 and -2. So in this case, the bisection theorem would find root A, but it wouldn't find roots B or C. Okay. Okay. No, I know. I knew this was going to
There's
go.
a positive number up here, and it's a negative down here, so it has to cross both sides.
Okay. Let me try and explain again. Let's try again. Give me another
It can just be a straight
Okay.
line.
So let's pretend that you only know, to start out, you only know the value at -2 and the value at +2, right? You know that at -2 the function has a positive y value, and at +2 the function has a negative y value. So if it has a positive y value on one side and a negative y value on the other side, it has to cross the x-axis somewhere in between those two, assuming it's continuous, right? Okay, cool. So that means there has to be a root in between -2 and +2. So the bisection method of finding the root is to cut this interval in half and look at the y value there.
What is a root?
A root is a place where it crosses the x-axis. We're going to pretend like you can't see the graph here, right?
How do you know where 0 is and then you see the graph?
Okay, so let's say that we have a function. Okay, let's do this a different way. So you have some problems on your assignment that are like this, but let's do this a different way. Okay, bear with me. All right, we're just going to do a problem directly from your assignment because I'm not creating this one. Let's say we have a function here that is f of x is equal to t to the 5th minus 3t plus 1. And we're looking at on the interval from 1 to 3. That's what these brackets mean, the interval from 1 to 3. So I want to see if there's a root in between those two. And the reason I want to see if there's a root is because we're going to pretend like you don't have fancy calculators that can do fifth roots, okay? Or actually, no, you would even, the fifth root wouldn't even solve this. It would be way more complicated than that.
Oh my god.
Wait, does this root have any relation to square root?
It kind of does, yeah. So like fifth roots and square roots, fifth roots you're looking for what number of times it's off? 5 times makes a number?
You're talking about like the x.
Oh, no, yeah, no.
Alright.
Okay, sorry. Thank you, Kelson. Okay, so what I'm going to do first is I'm going to evaluate f of 1. I'm going to find out what that is. And then way over here, I'm going to evaluate f of 3. Now, here's how you can make your life so much easier because of the calculator that you have. All right? So, rather than typing 1 to the 5th minus 3 times 1 plus 1, instead, I'm just going to go to my calculator. Wait a minute. This is another way of doing the same thing, just without having a graph.
It's like a formula for a graph.
Right. So like now you really don't have the graph between these two.
And that's what.
Right. Which is, I'm doing a bad job. I'm trying to do better, okay? Just give me a chance. All right.
It's not your fault.
It's not your fault. Okay. So I'm going to type in x to the 5th minus 3x plus 1. I'm going to use the x variable here. So I'm going to do x to the 5th minus 3x plus 1. And then I'll hit enter. And it'll give me back a value because I already have a value stored in for x. But don't worry about that right now.
99,000.
I got 2.8.
You what? Right. I know. Give me a second. Or actually, let me look at that after, and we'll fix that. Okay. So here, we've got our function here, but this will like spit up a value because you already have something stored for x. So I'm going to do 1 store, and the store button is down here. Is it negative? No, it's 1. I'm going to do 1 store for x, enter, and it's okay. It's like, okay, yes, x is 1. Then I want to re-enter that function up there. So second enter. And now when I hit enter, it'll tell me what f of 1 is. So f of 1 is...
It's like what we did with that thing. What was that thing that we did to enter in all the bunch?
The composition of functions?
We're not doing wrong.
I don't know. Give me a second. I can check. So we're going to do 3 store for x now.
1.47, and that's definitely wrong.
Yeah. No, it's super wrong. Okay.
35.
So let me go help Michael here. Because second enter, if you're using Reese's calculator, you arrow up like 3 times and hit equals.
Wait, I get 3.
You stored it for the wrong x. You stored it for capital X. You need to do 1 store x.
Yeah, the first equation does that. Your x, you have to store it.
There you go.
Oh. No?
Very first one got
I have on my
99,000.
phone.
Oh, the very first.
Right, because you did 1 store for plus, you need to do 1 store for x. Okay, cool. And now go to your function, so the x to the 5th minus 3 plus 1.
Because I'm leaving. We're leaving like
Let me get back into that.
You get reduced it, right?
Okay.
Oh,
You should be anyway.
that's my other password.
So. In between in between 1 and 3, the function goes from -1 to positive 235. So it definitely crosses the x-axis in between these two values. So what's directly in between 1 and 3? 2.5, right? Or not 2.5. Yeah, 2. Geez, what am I thinking? I'm sorry. So I'm going to evaluate the function at 2 now and see what that is. So here, I'm going to do 2 store for x. And then I'm going to do the same function I did before again. And I get back out 27. Now, these are both positive, which means there could be a root in between these two, but there doesn't have to be. So I'm going to focus instead on 1 and 2 now. And now I'm going to bisect that. Yeah, because it's going from negative to positive here, and here it's both positive, so it definitely, it might cross the x-axis, but it doesn't have to in between these 2 points.
14 or
Why
14.
wouldn't it if it was
Because if they're both negative, then you know that at one point it's here and at one point it's here, and it could cross the x-axis.
But it could also be a straight line.
Right. Or it could be something that does like that.
Or like a negative parabola.
Yeah, if they're both positive, they're up top. But with these two, one's positive and one's negative. So between these two, there's a cross of the x-axis. Yeah. So we're going to do f of 1.5. So I'm going to do 1.5 store for x.
I get it. The x value, not the y.
Yeah. And I get 4.09. Now, there doesn't have to be a cross of the x-axis in between these two, but there has to be a cross of the x-axis in between these two.
God, no.
So I'm going to bisect it again.
1.25.
Right. And actually, what I'm going to do, yeah, let's do 1.25. So 1.25 store for x, and I get 1.25, or yeah, because I didn't actually, and I get 0.30. I know, I told you this wasn't going to be easy. I wasn't lying to you. So now it has to be in between 1 and 1.25.
So 1.1.
Right, so let's try 1.1. I know you're excited about this, Faith.
175.
Yeah,
Let's put 1.17.
do 1.1.
Let's just do 1.1.
Trying to find a negative number, right? Or 0.
You're trying to get close to 0. Okay, so here's negative.
Oh, no, 1.1.
Okay, now, for your assignment, okay, it just asks you to get within 1/10 of where the root is. So we know at this point that the root is in between 1.1 and 1.2. So your answer would be between 1.1 and 1.2.
Sweet.
We don't have to find exactly where the root is, but we know that the root has to be between 1.1, which is where it was a negative value, and 1.2, where it was a positive value. So it's in between those two.
All right.
Faith, you look really upset right now. Okay. Let's take a look at your assignment, because that's as hard as it gets. I know.
What
Yeah.
a deal.
I just don't get why you can't, I just don't get why you can have two negatives, why you can have.
Because it could be a
You
straight line.
could have a root, but you don't have to have a root. Mr. Browning,
How do I make a dead
Sending
pixels?
the positive,
Yeah. Oh, it's annoying.
I asked for you.
but you have to have two if it's positive.
You know,
What?
I'm like,
Oh.
you know what?
But you have to what?
Pain.
Jason's talking, I can't hear you. Don't get mad at me. Trying to help.
All right, so let's go through this. Your assignment is 5 through 17. No, 5 through 17. All right. So let's take a look here. So we got 5 through 17 as our assignment. Now, question number 5 and 6 aren't too bad. I'll go through 5 with you guys. You can do 6 on your own. So in this situation, we've got x values and we got y values. X goes from 0 to 5, and the y values are 5, 3, -2, -1, 3, 2, or -2. So if you imagine graphing this out, it starts out at 5, goes down to 3, goes down to -2, -1, 3, -2. So how many times does it have to cross the x-axis in between those? Count again. 1, 2, 3. Yeah, no, you can just fill in the blank. It has to have at least 3 roots between 0 and 5. Okay. I know you were. You're like 2. 2. Okay, f of x equals 4, meaning y equals 4, at least blank times. So from 5 to 3, it has to equal 4 somewhere in there. And then there's no other place where it has to go up to 4. It might, but it doesn't have to. There's only one time when it has to equal 4. F of x equals 2 at least. So it has to equal 2 somewhere between 3 and -2, somewhere between -1 and 3, and somewhere... Yes. Bless you. F of x equals 3 at least 2 times. And is it possible for f of x to equal 7 for some value between 0 and 5? Just, is it possible?
Yeah.
No.
It is possible.
Oh my god.
Nah.
Because, Faith, the graph doesn't have to follow this. The graph could jump like,
So we just put yes.
like that. And then it could equal 7. So yes, it's possible. So we know for sure that it crosses in 3 places, but the graph could be like way more whimsical than that. Okay? Number 6 you got on your own. I'm actually going to have you guys skip number 7, so you can cancel out number 7.
We don't do number 7?
Yeah, you can skip number 7.
Awesome.
Now,
A lot of letters.
let's take a look at number 8 here. Number 8 and number 9 are very similar. So 2 students claim that they both started with the points 0 and 5. Okay, great. Applied the bisection algorithm to the function in figure 17. First student says the algorithm converged at the root labeled A. The second student claims the algorithm will converge at the root labeled B. So number 8 is very similar to this, but we're doing number 9. So if we look at 0, the function at 0 has a negative value, and the function at 5 has a positive value. So does there have to be a root between
Yes.
those two?
Wait.
Yes.
What in the world is convergence?
It means goes to. All right.
Yes.
Aside from divergent, divergent means goes away from.
All right.
Okay, so there has to be a root between these two because this one's negative and this one's positive. So we're going to go to the middle, just here. The value in the middle is negative. So does there have to be a root between 0 and 2.5?
No.
No. Do you see that? Because they're both negative, even though we know what the graph does. It could not do that. It could just go like, meh. Right?
Yeah, but doesn't it do the same thing for positive? So like, why?
Right, but these aren't both positive. This is negative and positive, which means that there has to be a value. Right, if they were both positive, you wouldn't do that either.
Well, you said there has to be a
No, between positive and negative, there has to be one.
Oh my gosh. Listen.
I know you don't, Michael. It's okay. So now, I'm going to cut this in half. When I get there, I'm going to cut that in half. So it's actually converging towards C.
So they're both wrong.
Yeah, they're both wrong.
Wait, but then you write that they're both wrong?
Yes, you can.
They
Just write
both
it.
wrong.
Yeah, say they're both wrong. Neither of them. Okay. Let's take a look at question number 11.
Wait, what are the numbers you're going to?
So you're doing 5 through 17, but you get to skip 7. Let's look at number 11 here. I know, I'm excited too.
No, you skip 10.
Yeah, I skipped 10. 11 is just like 10.
I know, but
10 looks harder.
It's super not. Okay,
but it means it's
so number 11.
Yeah, I know.
If you apply the bisection algorithm to the function in figure 19 and use the given starting points, what roots does the algorithm find? So we're going to start at 3 here and 7 here. So we're going to cut that in half. So that's going to bring us here.
all right.
So does that find B, C, or does that find D? Because like it's going to find D. It's not going to find B or C because both of these are below 0. So it's going to find D.
So we just put D,
Yep.
right?
Yep. Starting at points 5 and 6. So here's 5. Here's 6, a little bit above. There's only one root in between those two, so there's only one root it can converge towards. Yeah. 1 and 6. So now if I cut those in half, that's going to bring me to 3.5, which is here. And then if I cut that in half, meh. Meh, meh. Okay, we did 14 as part of your notes, so let's do, which one has sign in it?
16.
Let's do 16, since you guys are all super scared to sign.
Oh, these are the ones that take long.
These are the ones that what?
Take a little while.
Yeah.
So these take.
When I did it, it took me about a third of a page for each of those.
What was C again?
C
Third of a page?
was B. Yeah,
Each of these?
yeah.
Oh my god.
You're a big kid, man. Come on. You can handle
Or
it.
rather long.
You're in big kid math. You're a big kid too.
I
Okay. 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 So for number 16, the first thing I'm going to do is make sure my calculator's in radian modes, since it gives a pi.
How do you do that?
Second, more, we'll bring up the mode and make sure radian is highlighted. And I'm going to exit from there. Now I'm going to enter sine parentheses 2x close parentheses minus cosine parentheses x parentheses. Now it still has the same value it had for x just a minute ago. So what I'm going to do first is I'm going to sub 0 in for x and then bring up that previous entry and I get negative 1. So f of 0 is negative 1. I'm going to write that way the heck over here. And now I'm going to find out what f of pi is. So if I substitute in pi, and to get to pi it's second caret, I get back out positive 1. So between these two values, there has to be a root, right? Between negative 1 and positive 1. So we're going to bisect it. So what's half of pi? Pi over 2. So we're going to use pi over 2. And we're going to do second pi divided by 2 store for x. Meh. And second enter. Meh. And we get back out 0. That's the root! Right there.
Okay, I don't know.
That's it.
Second clear?
Wait, so that was it.
Nope.
Second variable to store.
So,
Or control variable, not second. Control variable.
I know where the store button is, but like, I don't know how to do that.
Okay.
Pi over 2.
No, that's not the root. Do it. 14, yeah. Or wait, no, it's
Okay.
Pi over 2.
So,
yeah.
I know you're excited.
Zero equals negative
Okay, now, first I'm going to do
one. What? Store?
16.
Actually, that's what we started.
This is what we just did. Alright. I'm going to start at 12.
Yeah, I'll sort yours back. Now, to bring this equation back up. Parallel coefficient here. So negative 2 is the value of 1.
Alright.
And then you can throw in 1.
Yeah, but because it's a
And then you
we go on the language.
So between negative 2 and 7 is the x is 0.
So, and then because of the lag from sitting for 4 hours, we're gonna get all our rings are put in a day. Get back to normal. Stack it there. Get both back to the hour.
How do you
Then we're gonna
store it? So I store it to-
Yeah, we always so I discussed 21. Yeah. Now it's time for 0.75. 0.75.
Now,
So it has to be,
you find out what
wait, between 10. I got a negative number.
now.
Those sucks. Yeah. No, 0.
So
Yeah, negative 2. What?
Yeah, so like, then you have to try 1 point.
Okay, so it's just 5 taxes, you can check that we have to within 1 tax, that's all.
This is why I hate that.
Still not though.
This is why I hate that. I'm gonna charge money to do. Oh my god. It's still in that.
It can't be 1.4. They charge block it.
Well, it can't be 1.5.
One of those for that college and everything, so I might charge that one.
Dude, I'm at 1.4.
They're 1.1.
Ah. 1.35 to 1.4.
I know.
Come on, people.
But there you go.
Yeah. Okay, so
For 12.
oh my here's actually
God.
the easiest way you can do that.
Yeah.
So if you're looking at 0 through 5 on the x-axis, yes. Negative 1.
Catch for AD.
Yep. So this is going to go at least like that. So how many times does it cross the x-axis? Which I know you already have answered. Great. Now, f of x is going to be equal to 4. So I'm just going to go 4 here and draw a line across. How many times does it have to be equal to 4? Touched it right here. So it has to be equal to 4 at least once. F of x equals 2. So if I go and just draw a line at 2, 1, 2, 3, at least 3 times. F of x equals 3. At least 2 times. And then, is it possible for f of x to equal 7? It is, because this doesn't have to go like this. It could go like, could go like that. And it would still hit all those points, but you could have it be 7 like a bunch of times in between there. Kind of, sort of?
Oh,
Right. So, same idea behind it. Yes.
For AD.
Mr. Brown.
I don't. There's so much done. Where it should be on 60.
Yeah, no, it's possible.
End of question.
Because 3.14 is between -1 and 4, right? No, but so like the highest it goes is 4. -1. 3.14 is the range that we got.
Oh my god, I hate
So
myself.
the 3 we have to go between all of
Oh yeah, no, it's super possible. You can go up and down.
Everybody, oh, so should we have to go through all those points?
Aha. Oh wait. Oh my god.
13?
I'm an idiot. I am an idiot.
You have to get
Yeah, so, oh, okay, no, don't do all those points, just do -1 and 0. Thank you for pointing that out.
On 13,
Yeah,
it's you get an answer right away. So
yeah, just do -1 and 0. For some reason I missed that when I did that. Okay.
is there only gonna be one?
Yeah.
Is there sticky notes in that drawer? Over there somewhere?
Not in the drawer, in the cabinet or graphics.
doesn't do 8.
I did not do 8. I'm doing